4.2 is coterminal and related angles. So we're going to start with coterminal angles because they're extremely straightforward, and then we're going to get into related angles, which are extremely important for this chapter. So let's take a look at what a coterminal angle is. So coterminal means it shares the same terminal arm. So a terminal arm is just an arm that rotates around a circle that makes an angle with the x-axis over here. So this is, let's say, 30 degrees. I just made that up. So it's angles that share the same terminal arm. As this rotates, the only time it's going to share a terminal arm with this one is if it rotates a full 360 this way or a full 360 this way. So coterminal arms are just 360 away from each other. It's that straightforward. So if I have to find three coterminal angles to 30 degrees, I can do that by just saying 30 plus 360 equals 390 degrees. But I could also say 30 minus 360, which is negative 330 degrees. So just a reminder, when we rotate clockwise in this unit circle, that's negative degrees. And when we rotate counterclockwise, it's positive. So for instance, this is positive 30. If I want to say negative 30, I write it down here. And negative 30 is the same as positive 330, right? Because I'm 30 away from that 360. Okay, so there's a lot of ways to say it. But all you have to do is add multiples of 360 to get a coterminal angle. Okay, so for instance, I can even add another 330 to this, because the question says three of them. And that's 720. 720 degrees. That's one coterminal angle, another coterminal angle, another coterminal angle. All three of these angles are coterminal angles. If I had to find sine of 390, sine of negative 330, sine of 720, all the answers are going to be the same because they are coterminal. It's really based on the same angle. So now we're going to take that further and talk about related angles, and it'll kind of explain why exactly coterminal angles are in fact the same. Okay, so related angles. Before I go into related angles, I just want to give you a little heads up that the primary trig ratios are just sine, cos, and tan. So if a question is asking you list the three primary trig ratios, you're just finding the sine ratio, the cos ratio, the tan ratio, and you know that through SOHCAHTOA. Okay, so now, related angles. I put two angles here. One is 120, one is 225. So we use related angles when we're outside of the first quadrant. Okay, so anything greater than 90 degrees, in order to calculate that, we use the related angle. And the related angle is the distance of that angle to the x-axis. Okay, so just like this is 30 degrees away from x, if I'm saying 120, I really want the angle that's under here. Let me use black. I want to know what this angle is. Because if I know what that angle is, I know how far it is from 180, and I can solve my primary trig ratios easily using the related angle because it is an acute angle. And using our special triangles, those are all acute angles. So now, how do I figure out this angle? Really straightforward. If I know this is 120 and this is 180, I'll put that here. This is 180 degrees, always, this line. This is the difference, 60. So theta in this case is 60 degrees. So the related angle to 120 is 60. So if I had to find sine of 120, I'm not going to use anything obtuse. I'm going to use the acute related angle. The acute related angle is sine of 60. So I know sine of 60 using my special angles from 4.1. I can figure out sine of 60 and apply it to the sine of 120. Okay, these are the same. They are equivalent. Okay, let's take a look what happens when we do 225 now. So 225 is 45 degrees away from 180. So the related angle for 225 is 45 degrees. So if I'm finding sine of 225, this is the same as saying sine of 45, which I know using my special angles again. I can convert sine of 45 to 1 over root 2 or root 2 over 2, whatever the case may be. Now, after you find the related angle, there's one last thing you have to do. You have to consider the sign of the function. And I remember showing you in 4.1 that we know the cast rule. So with the cast rule, we know if the sine ratio, cos ratio, tan ratio, or all the ratios are positive or negative. So let's take a look at 120. 120 is right here. It's in the sine positive quadrant. So sine of 120 and sine of 60, these are the same. They're positive. But look at sine of 225. 225 lies in the tan quadrant. So only tan is positive here. Sine and cos are both negative. And you can see that by knowing that sine is actually vertical distance, so we're below the x-axis. And cos is horizontal distance, so we're to the left of the y-axis. So we know that they're both negative over here. Now, if I'm finding a sine ratio in this quadrant, it has to be negative. That's it. So yes, sine of 225 is the same as sine 45 in terms of its absolute value, but I have to make sure my last step includes the sine. So you do everything the same way to find the related angle. Just use your cast to figure out your location and pop that sine in there. Okay, and that's pretty much it for related angles. Now we're going to go into some examples using our special angles. Okay, so for this question, we know that sine theta is 3 over 5, and angle A, actually, sorry, we're going to change this to A because they should be the same as the angle. So sine of A is 3 over 5, and angle A lies in the first quadrant. So I know that angle A is here somewhere in the first quadrant. This is A. If sine of A is 3 over 5, let's see what that means. Let's create a triangle using this. And if angle A is that angle right here, sine of A is opposite over hypotenuse. So the opposite is 3, the hypotenuse is 5. Now, if I want to determine the exact values of primary trig ratios, I need sine, I need cos, I need tan. Well, I already have sine theta, 3 over 5, done. I'm only missing the other two primary trig ratios, cos and tan. Both cos and tan include the adjacent side. I don't have the adjacent side. So this is a right angle triangle. I can use Pythagorean theorem to figure out that last side, or I understand the 3, 4, 5 right triangle. So I immediately know that this side length is 4. Okay, so again, if you don't know how to get 4, use Pythagorean theorem, 5 squared minus 9 squared, square root of 4. All right, now I have all three sides. I can conclude with my primary trig ratios. I know that sine of A is 3 over 5. I know that cos of A is 4 over 5. And I know tan of A is 3 over 4. Okay, so this is the exact values of the primary trig ratios. Done, done, and done. Okay, so here we want to determine what other angles have the same sine value as 30 degrees, cos value, and also tan value of 30 degrees. So here's my diagram with 30 degrees. And we're going to use the related angles to figure out where else these things are the same. So let me bring your attention to the cast rule again. You're going to be using this every single time. Cast, forever, for trig. Okay, we need to know each quadrant if it's positive or negative. It's a very important thing to know. So let's talk about sine. Sine of 30 degrees has a particular sine ratio. I don't really care about the sine ratio. I know the angle's 30. Sine also has a positive ratio here when this is 30. So this angle from starting position is actually 180 minus 30. So if I'm answering this question, I know that 180 minus 30, sine of 150 is the same as sine of 30. Okay, so 150 degrees is that other angle that has the same sine value because sine is positive here and it's also positive here. That's why the value is the same. Okay, there are technically 4 different possibilities. Up here, right here, right here, right here. It's always formed with the x-axis. Okay, I'm going to say that one more time. The related angle is always formed with the x-axis, never the y-axis. Okay, so let's take a look when we do cos. Cos is positive here. Well, where else is it positive? Here. Cos is positive here. So my related angle is here. And like I said, it always has to be with the x-axis, 30 degrees. What angle is this terminal arm from starting position? Well, if I rotate all the way around, it's really 30 away from 360. 30 away from 360 Okay, we can subtract those. 360 minus 30, and this is 330 degrees. So this angle in starting position is 330 degrees. Okay, but we use the related angle to figure that out. Okay, now lastly, tan. Tan is positive here, so tan of 30 is going to be the same as tan of whatever angle is over here. So I'm going to draw my angle here, and I'm going to use the x-axis to anchor my angle. Okay, this is all, they're all the same. These are all related angles in here. They relate to 30. Now, tan of 30 is the same as 180 plus 30, because this is where it's positive in here. So tan is the same as 180 plus 30 is 210 degrees. Okay, so the other angle that has the same tan value as 30 is 210. Okay, so can't stress enough that you have to stay against the x-axis. You can kind of think of this as you connect these and you create the vertical distance in each one. Kind of looks like a bow tie. So all the angles are always against the x-axis. There's 4 of them, and we're always using 360 minus to get into this quadrant, 0 plus in this quadrant. I mean, that's the easy one. And then over here, we're doing 180 minus and 180 plus. So depending on which quadrant you're in, you're always doing 180 minus, 180 plus. Okay, so if you're looking at the back of the book and there's 2 answers for a lot of these questions, it's because there's always 2 ratios for sine, cos, and tan that are the same, whether they're both positive or both negative. So for instance, sine is positive up here, but negative down here. So if this is one of your answers for sine, this is another potential answer because they're both the same values down here. They're both negative. Likewise, they're both positive up here, like we did in this question. Okay, so please consider the 2 different answers when you're doing trigonometry. One is always going to be the acute angle, and one will be the obtuse angle. And that's 4.2.